Today our focus is on tree diagrams and using the fundamental counting principle. What are tree diagrams? They are simply a way of showing the possibilities of two or more events. It's a simple diagram that we use to calculate the probability of two or more events. So we're going to notice, first of all, yes, it is a way of showing the possibilities. And secondly, before we get into calculating probabilities of simple events, we're going to illustrate the probabilities of simple events. And so one way we can do that is using a tree diagram. So let's assume that a fair coin is flipped twice. A fair coin has heads on one side, tails on the other side. We want to illustrate the possibilities for all of the outcomes if we were to flip the coin twice. So on our first outcome, our first event. Our first event is us flipping the coin the first time. When we flip the coin the first time, it has the possibility of getting a heads, or it has the possibility of getting a tails. Notice that I've used abbreviations. This will help save you a lot of time, especially when we get into some of the illustrations that have bigger words or phrases. If you can abbreviate and I can understand what your abbreviations are illustrating, that's fine. Now, so far all we have done is illustrated the outcomes if we flip one coin one time. I could get a heads or I could get a tails. Well, now we want to account for the second event, flipping a coin a second time. Since the outcome of the second event is dependent upon the first event, we're going to have a branch that extends off of each of the first events. So one off of the heads, one off of the tails. Now we can list our outcomes for the second event. The second time I flip a coin, it still has the possibility of getting a heads or a tails. And that same possible outcome applies no matter what our first event's outcome was. Now we need to look at this chart, and those of you who are used to reading a March Madness chart, you're going to look at this and say, hey, this looks a lot like brackets. Certainly. In your March Madness, you would read these are the teams that are playing, and the winner reduces down to where we eventually have a grand champion. Now, the tree diagram is read the opposite direction. We start with our first event, which has the option of getting a heads or a tails, and then we layer on the second event. So assuming that I had gotten a heads on the first event, I could have gotten a heads on the second event. So one possible outcome is a heads and a heads. Assuming that I got a heads on the first event, I could have also gotten a tails on the second event. So a second possible outcome for flipping two coins is that I could have gotten a heads followed by getting a tails. Next, it's possible that I didn't get a heads at all on the first event. Again, we're looking at possible outcomes. So it's possible that instead of getting a heads on the first first flip, I got a tails on the first flip. So tails would be my first outcome. Heads would then be my possible second outcome. And then it's also quite possible that I got a tails on my first flip, but a tails on my second flip. So both of the outcomes would be tails, tails. So we've now used a tree diagram to illustrate first event, second event, and remember the second event's outcomes get replicated, attached back to both first event outcomes. And then we end up with our list of possible outcomes, which is simply reading our chart. Following from the beginning, we end up with heads. Heads is one possible outcome. Began from the beginning, we go through and heads, tails is a secondary possible outcome. From the beginning, tails, heads is a possible outcome. From the beginning, tails, tails is a possible outcome. There are 4 possible outcomes. You have a spinner cut into thirds with red, blue, and green sections. Draw a tree diagram to represent all of the possible outcomes of spinning the spinner 2 times. Now you're going to do this on your own using the example from the previous problem. So your event 1 would be spinning a spinner with the outcomes red, blue, and green. Your event 2 is going to be spinning a spinner with the outcomes of red, blue, and green. However, remember, red, blue, and green need to go back to your first red outcome. They also need to go back to your first blue outcome, and they also need to go back to your first green outcome. Now that you have your tree diagram, you can follow through your possible outcomes. So you should be able to look at your tree diagram and see that you have a red, red as an outcome, a red, blue as an outcome, a red, green as an outcome. You have a blue, red as an outcome, a blue, blue as an outcome, and a blue, green as an outcome. You have a green, red as an outcome. You have a green, blue as an outcome, and you have a green, green as an outcome. So how many total outcomes do we have? We have 9 total outcomes. The fundamental counting principle of multiplication. If an event occurs in m ways and another event occurs independently in n ways, then the 2 events can occur in mn ways. Now I know at this point you're probably thinking, hey, that doesn't make a whole lot of sense. That's fine. Take just a second to write it down. Pause the video if you need to, so that you can get it down word for word, because this is the fundamental counting principle of multiplication, and I'm going to expect you to be able to know it pretty well in its entirety as it's written. If an event occurs in m ways and another event occurs independently in n ways, then the 2 events can occur in mn ways. So, for example, if you have 3 pairs of pants and 7 shirts, how many different ways can you choose a pair of pants and a shirt? So one event has 3 outcomes, another event has independently 7 outcomes. Combined, there would be 3 times 7 total possible outcomes. So 21 outcomes. Now before you finish, I want you to think of, when do I use a tree diagram and when do I use the counting principle? The tree diagram is used to show the possible outcomes. The counting principle is used to tell the number of possible outcomes. So if you're expected to show them or list them, you could certainly use a tree diagram. If you're just expected to state the quantity, then you could certainly use fundamental counting principle. It's going to be much quicker than drawing an entire diagram.